In this module, we're going to be looking at reactions. Specifically, we're going to look at how to predict the products of a reaction. From our previous module, remember there are 5 classifications of reactions. Each of those classifications are going to have their own types of products based on what type of reaction it is. First, we're going to look at combustion. Remember, combustion is an organic compound and oxygen combined together. So this is an example of a combustion reaction, octane plus oxygen. Combustion reactions are the simplest to predict the products because in a combustion reaction, the products are always carbon dioxide and water. So if you know it's a combustion, and right now any reaction that has an organic in it is going to be combustion, it's going to give us CO2 and H2O. Second type of reaction is a synthesis. That's where 2 elements or simple binary compounds come together. Remember, in a synthesis you want to have more reactants than products. One example is combining sodium and chlorine. In this example you see that we have 2 elements, and if we have 2 elements, combine them to make a compound. Sodium is a metal, chlorine is a nonmetal, so it's going to combine to make an ionic compound. In this case, that ionic compound would be sodium chloride. You could have 2 binary compounds like magnesium oxide and water. Binary compounds. If the binary compounds are a metal oxide and water, they are going to combine to make a hydroxide, which is an ionic compound. Magnesium is a metal, so the magnesium oxide and water will make magnesium hydroxide. Please make sure that you follow our correct formula writing rules for it, and that we have the correct formula for magnesium hydroxide, which is MgOH in parentheses 2. Second option we could have is you could have something like SO3 plus H2O. Again, 2 binary compounds. In this case, SO3, sulfur trioxide, is a non-metal oxide and water. And a non-metal oxide and water will combine to make an acid. So you just put them together to make whatever acid makes the most sense. SO3 and H2O will come together to make H2SO4, and following our good naming rules, we know that to be sulfuric acid. So, these are the rules for a synthesis reaction and predicting the products. Decomposition. In a decomposition reaction, we start with 1 compound, and you're going to have more products than reactants. So we can start out with a compound like iron 3 chloride. Iron 3 chloride is a simple compound. It will break apart down into its elements. So iron 3 chloride will break down to iron, which is just Fe, and chlorine. And elements whose name end in INE or GEN are going to be diatomic in the elemental form. That means when they're by themselves, they have the subscript 2. So GEN, hydrogen is H2, nitrogen is N2, oxygen is O2, fluorine is F2, chlorine is Cl2, bromine is Br2, iodine is I2. So chlorine, because it ends in INE, is going to be a diatomic element. So iron 3 chloride will break down into iron and chlorine. Could have a little bit more complicated of a product like MgCO3, which is magnesium carbonate. And whenever we get a carbonate, carbonates will break down into a metal oxide and carbon dioxide. So if this was magnesium carbonate, it will break down into magnesium oxide and CO2. So magnesium oxide and carbon dioxide will be the products of the breakdown of magnesium carbonate. Double displacement reaction always starts with 2 ionic compounds. So we could start out with silver nitrate and iron 3 chloride. When we work with a double displacement reaction, you always want to make sure that you have the names for the chemicals. So look at the names of the compounds and switch the cations or the first words. So silver nitrate and iron 3 chloride will become iron 3 nitrate and silver chloride. Once you have the names, then you write the formulas just like you would if you were given them outside of a reaction. So iron 3 nitrate becomes FeNO3 in parentheses 3, and silver chloride becomes AgCl. Last type of reaction is a single displacement. A single displacement will have an ionic compound and an element. So this could be our reaction. Aluminum is an element, and copper 2 nitrate is an ionic compound. So this is going to be a single displacement reaction. To predict the products, again, you want to put everything into words, and the element will replace the same type of element in the compound. As I look at this, aluminum is a metal, so it will replace the metal in the compound. The metal in the compound is copper 2, so aluminum and copper 2 nitrate will make copper and aluminum nitrate. I do not put the Roman numeral 2 with copper because as an element it has no charge. So then I write the formulas for the new substances. Copper would just be Cu, and aluminum nitrate would be Al, NO3 in parentheses 3. So everything we've done here tells you how to come up with the formulas for the products of a chemical reaction. Next step you would have to do is you'd want to balance them, but that will be for the next module. This ends the module on predicting products.